So let's provide a solution for this question. Applied mechanics. The topic is based on friction on an inclined plane. Suppose the question says an effort of 2000 newtons is required just to move a certain body up an inclined plane of 15 degrees with the force acting parallel to the plane. If the angle of inclination of plane is made 20 degrees, the effort required again applied to the plane again two times the is found v 2300 newton. Find the weight of the body and coefficient of the friction. So the first thing to do is to figure out our datas. Let's figure out the datas. We know that our given datas, they are of two cases. The first case we have 15 degrees Celsius, require a moving body up an inclined plane of 15 degrees Celsius, and with the force acting parallel to the plane with the angle inclination with theta 20 degrees Celsius. So from the first case, our what? The Newton, our effort, P is our effort. So therefore our effort is 2000 Newton. That was the first part. So the second part, but before then, we can say our effort should be P is equals to the weight multiplied by sine theta plus what? Plus mu. What is mu? Mu is the coefficient of friction. So let's say mu cos theta, the coefficient of friction. So for the second case, we are having theta is equals to 20 degrees. And our effort is 2300. So therefore the P should be 2300 Newton. Again, we're having the general formula. Let's say the general formula is P equals to sine theta plus the coefficient of friction cos theta. So we're having the value of phi. Let's say it's 2000. Yeah, it's 2000. And also here we're having the value of the effort is 2300. So we figure out our datas. The next thing to do, we know that the weight of the body is acting vertically, which was our weight. The weight is acting vertically, and also our force in Newton is perpendicular to what? To the inclined plane. That was the force in Newton, and our frictional force opposing the motion is given by the frictional force opposing the motion is given by F, which is the force is equals to mu multiplied by the normal force. So that is the formula. This is the formula for the frictional force opposing by a given force. So the next thing to do, and also we are having two values. The weight component can be represented into two. The first one is the parallel to the plane, which was what? W sine theta. The parallel to the plane, but the perpendicular to the plane is what? W cos theta. So this equation, P is equal to W sine theta plus cos sine theta, they are the equilibrium equation. This is what we call the equilibrium equation. Equilibrium equation. So we have already figured out our data. How can we apply those formulas to find the solution of this problem? So we have to have our second equation. When we have our second equation, the first equation that we have made, here we have to put our final phi, supposed to be the p. So we have to find the second equation from this value. So what is the solution of this? The solution of this will be 2000 W will be what? Sine 15 degree. We are having sine 15 plus the coefficient of the friction multiplied by cos 15. So here is the first equation. And therefore, our second equation, let's have our degree. Our second equation from this will be our P is, we know that our P is 2300, which is equals to the weight, and then the brackets, we're having our theta as 20 degree. So therefore, we have to say sine 20 degree plus mu cos 20 degree. So that's our second equation from this question. So have a sheet of paper and write this down, because we are going to continue with our solution. So the next thing to do is we have to donate sine 15 theta plus mu multiplied by cos 15 theta and sine 20 theta plus mu multiplied by cos 20 degree. So we have to let the first one to be A and the second one to be B. So therefore, let's say A should be sine 15 degree plus the coefficient of friction, which is mu cos 15 degree. So, and we have to let the sine 20 degree plus mu multiplied by cos 20 degree to be our B, the value of B. So let's say we have sine 20 degree plus mu cos 20 degree. So we have already let the first part to be A and the second part to be B. Okay, let's find the solution of the problem. If you could remember, the general formula that we have figured out for the equilibrium, we say that phi is equals to W into brackets sine theta plus mu cos theta. So therefore, we said complete the sine factor with the same with the mu should be A, and for the second part for 20 degree should be V. So from the first fact that we have said that for 2000 Newton, we say that 2000 Newton, which is equals to our W, and therefore for 15 sine 15 plus mu multiplied by cos 15, we let it as A. So therefore we are having A. And for the second one, which was 2300, which is our P, the effort, the second effort that is found as 2300, we let it as 2300, which was equals to the weight multiplied by, we let it as B for the 20 degrees Celsius multiplied by B. So what are we going to do next? The next thing to do is to let's divide the second equation by the first. Divide second equation by the first equation. Like how? We have to say second equation, this is our second equation, by what? by the first equation, which was 2000 Newton. We say we divide it by A. So if we divide them, you see that weight will cancel weight. We'll end up having 2300 over 2000 is equals to B over A. That's right, that's how we can do. So let's clean here. Let us leave the general formula for the equilibrium. So how can we solve this value? So we know that 2300 divided by 2000, we will end up getting 1.15, which is equals to 1.15 is the value of this. If you press in your calculator, it will give you this value. And therefore, B over A, we have to include our V all over A. So we have to figure out the value of V and also to figure out the value of A. So let's clean this. We already know that the value of B is for the 20 degrees Celsius. If you pause the video and get back to the video, you will see that the value of B, we let B as sine 20 degree plus mu cos 20 degree. So therefore 1.15 is equals to sine 20 degree plus mu cos 20 degree. Yeah, so we have to say over the value of A, which was sine 15 degree plus mu cos 15 degree. So that's all. So what are we going to do here? We have to cross multiply. But before we cross multiply, we have to first find the value of sine 20, cos 20, and also sine 15 and cos 15. So let's see here. Sine 20 will be, cos 20 will be, sine 15, and also cos 15 will be. So what the value of sine 20? Sine 20, let's press our calculator. Sine 20 will be 0.3420, 0.3420, 0.3420. So that's the value of sine 20. So what the value of cos 20? 0.9397, 0.9397. So let's see the value of sine 15. Sine 15, 0.2588, 0.2588. So what the value of cos 15? Cos 15 is 0.9659, 0.9659. So that's the value of it. So let's insert it. We're having 1.15, which is equal to sine 20, which we are having 0.3420 plus our mu multiplied by sine 20, okay, cos 20, which is 0.9397 over sine 15. We're having 0.2588 plus mu point, okay, multiplied by cos 15. We're having 0.9659. So we have to cross multiply. If we cross multiply, we'll end up having 1.15 multiplied by 0.2588 plus mu multiplied by 0.9659, which will be equals to 0.3420 plus mu multiplied by 0.9397. So if we multiplied 1.15 multiplied by 0.2588, we'll end up having 0.29297 plus 1.15 multiply. If we foresee mu multiply by this, we'll end up having 0.9659 mu. And if we say the value multiply by 1.15, we'll end up having 1.1108. 1.1108 mu. So that's all for this first part. Let's say that is equals to 0.3420 plus mu times 0.9397. So now, how can we do to find the value of mu? The first thing to do is to say 1.1108 mu. If we say mu multiplied by this, we'll end up 0.9397 mu. So let it cross the equal sign and it will become negative, minus 0.9397, and it will be equals to 0.3420. So we have like terms here, and if it crosses the equal sign, it will become negative sign, minus 0.297, 0.2976. So we're having like terms here, we're having mu. So we have like terms 1.10 minus this, we're having, let's calculate it and see, we're having 0.1711. 0.1711 mu is equals to 0.3420 minus 0.2976, we're having 0.0344. 0.0444. So how can we figure out our final answer? We say 0.1711 mu is equals to 0.0444. So we have to divide both sides by 0.1711 mu, and also here 0.1711 mu. 0.07 will cancel, 0.1711 will cancel. So therefore the value of mu, it is equals to, let's calculate it and see. Sorry, we don't have mu here. 0.25, let's take it and see, 0.259. So that's the value of mu. So the next thing to do, the question say find the weight of the body and the coefficient of friction. So you can't find the weight of the body without the coefficient. We first find the coefficient of friction, and then we have to use the formula to find what? To find the weight. This is our weight. So therefore this is the value, the final solution for the coefficient of friction. So we have to use this formula. Say P, we have to insert the value of sine 15 degree plus mu multiplied by cos 15 degree. Find the weight of the body and the coefficient applied to the friction. We are not using this, our second inclination. The second inclination for this and this, we are to put and insert for the 15 degree in order to find our what? Our weight. So therefore the first, let's insert the formula P in the first part, we are having 2000, which is equal to weight we are looking for. So therefore, we see sine theta. So what is our sine 15? We have to use 15 for this part. We have to use 15. What is sine 15? Sine 15, we're having 0.2588, 0.2588, and therefore plus the value of mu, 0.259, multiplied by the cos 15. Our cos 15 is 0.9659. So how can we end up with calculating our final answer? We all know that this is just a substitution. 2000 is equals to the weight 0.2588 plus 0.259 multiplied by 0.9659 will end up having 0.2509. So 2000 is equals to weight. This plus this. What are we having? We're having 0.0509. So therefore, say 2000 is equals to 0.509 weight. So we have to divide both sides by 0.509. 0.509. This will cancel this, and we'll end up having 2000 over 0.509. We're having 3,929. 3,929 newtons. So this is the final value for W. W is equals to 3,929 Newton. So here is the final solutions, the two final solutions for this question. I hope this video is more helpful to you in calculation on how to calculate a question under friction on an inclined plane. Thank you for watching.